So the second part of 3.1 is still exponential notation or exponential functions, but we're base E. Remember we talked about E? It is a number. It's like pi. We use E instead of 2.718281828. You need to know that E is approximately 2.7, so bigger than 2.5, less than 3. And we have these as natural base. That's just what they're called. I don't know exactly why, but I always remember natural things come from the earth, so we have an E. Probably not why it's an E, but it's the way I remember it. So everything else is the same. Em, are you good if I go?
Yeah, I was just
okay. Everything else is the same as far as, I'm going to go back to your growth function. You don't need to rewrite it. Everything would be exactly the same with the natural exponential function, except it'd be e to the x. And other than that, everything is the same. The y-intercept is 0, 1. The domain is all real numbers. The range is greater than 0. It's increasing. Nothing's changed. Okay? Okay, so take your calculator out real quick, just so you know where the E button is. And so you're going to be taking e to the -2 and e to the 1/4, or 0.25. Where's the E button?
mine's above the division.
There's one above the division, and there's another one.
It's above n.
It's natural log. Above the natural log, they have the exponent already there. So, whichever one you would like to use. Oh my gosh. So you should get approximately oh my gosh, 0.1353.
Drink water upside down.
And approximately 1.2840. Is that what you guys got? Okay. Application. So the whole point of this is to use it and apply it. Exponential functions, like I said, are used in a lot of things. One of the things they're used in is interest formulas. One of the most familiar examples of exponential growth is investment, earning continuous compound interest. So we start with compounding yearly. The compound interest formula, it's P of T, principal after time, equals P times 1 plus R to the T. P is the principal. What does it mean, principal?
Like the
Personal finance, guys. What's principal? What you start with. R is your annual rate of interest. T is time in years. So 6 months is how much of a year? Half. And P of T is your new balance. So P is beginning balance. P of T is your new balance. You should know this formula. It is a formula that it's on the ACT. It's an expected formula for you to know. Got it? Alex, you good?
Mm-hmm.
Okay. So, oh, wait, real quick, come back here. I want to talk about it. We said P was the initial, yes? And R was your rate. T is the time in years. Why is there a 1 here? Do you guys know P, do you know interest equals principal times rate times time? You ever seen that formula?
No.
Never seen that formula either. Okay, interest equals principal times rate times time is the very basic interest, and it only finds interest. But here I'm finding the interest plus the principal, correct?
Mm-hmm.
Okay, so this 1 is your principal. It's the initial amount. Because if I distribute the P, I get principal plus the principal times the rate, don't I? Okay, so that's what's happening. Now, you can't distribute into it because of the T, but you'd have the T on it too, right?
Mm-hmm.
Okay, so that's where it comes from. So this is the compound interest formula, or compound yearly formula, compound interest, I can't talk. Okay, now you're going to get what happens if it's not a full year. What if it happens, I shouldn't say that, if it compounds quarterly or compounds daily. So compounding means I'm giving you interest. This formula was yearly interest rate. So how many times is that a year? 1. Yes? So what if it is monthly? Does that change? Yes. Okay, so look at this formula, and before you start writing it down, is it similar to what you just had?
Kind of.
What's changed?
There's an N.
There's an N. The R is dividing, the N's dividing the R, yes? So the N is the number of times it compounds in 1 year. You actually could use this formula every single time, because if it only compounds once a year, R divided by 1 is just R, correct? So if you're remembering one formula, which formula should you remember? This one? So P is still principal investment, starting balance. R is annual rate of interest. T is still time in years. A of T means the amount after time, new balance. And N is the number of times it compounds in 1 year. So quarterly is how many times? How many quarters are in a year?
4.
4. Monthly is how many? 12. Daily?
365.
365. Okay. Weekly?
Good day.
Isn't it like 52?
52. Okay. So that's the only thing that's going to change. Now, the next formula, you got that one down?
Yeah.
Okay.
Hurt.
So this is the compound interest formula, right? Now we have compounding continuously. And you only use this formula when it says it is compounding continuously. What that means is as soon as it quits compounding, and what does it do again? Compounds again, compounds again, compounds again. Chemicals do it. They break down and build this way. Okay, so it is A of T. That should be A of T, not just A. I'll start locking that door. So A of T equals P. What's P stand for? What's P?
Principal.
Principal. E, guys? E is E. E is the number, right? And R? What's R?
Annual interest.
The yearly interest rate. And what's T?
How many years?
Time in years. So it doesn't really change the formula other than it's just PERT. Only use compounding continuously when it says what? Compounding continuously. Everybody's like, I don't know when to use it. If it doesn't say compounding continuously, guess what? You don't use it. So the two formulas you have are what? Compound interest and compound continuously.
We're gonna have all these equations in our homework.
There's two. Because the first one we made into the second one. But yes, you will have them. And I do expect you to be writing them on your paper, like filling them in. Because if I don't give you a calculator on the test, you're going to have to give me this filled in, correct? So, those are the two formulas you have. Okay, the total of $12,000 is invested in at an annual interest rate of 9%. Find the balance after 5 years if it is compounded quarterly, monthly, and continuously. I'm not liking writing in black. Okay, so principal after time or amount after time. I like amount after time. Is P times 1 plus R over N to the NT. Correct? So what's P?
P is the 12,000.
12,000. What's R?
Is that 9?
It's 0.09
Yeah.
is your R. And what's your T?
5.
5. So in quarterly, what is your N going to equal? 4. In monthly, what is your N going to equal? 12. And continuously, we are going to use PERT. P-E to the R-T. Okay, so A of 5. Why did it go to A of 5? Because of the T. Equals 12,000 times
1 plus 0.09 over 4
to the NT.
Oh.
So 5 times 4 is 20. Do you guys want me to write 5 times 4?
Yeah.
Okay. So you're going to put that in your calculator all at one time using parentheses. So do it. Make sure you put 12,000, not 1,200 like I just wrote down. And I always put just 20 in. I usually multiply those out. Okay, approximately, because we're rounding, yes? It's money, so I typically would round to the nearest cent. I got $18,726.11. Okay? So if it asks you how much you made, how would you figure it out? Right. So you made $6,726.11, right? Okay, so do the monthly.
Time is 12, right?
No, N is 12. Time is still 5.
5. Oh, 5 years.
Yep. Okay, did you get $18,788.17? So did I make much more just because it compounded monthly?
No.
No. So if somebody said, I'm going to give you an interest rate of 12%, which you're not going to get, 12%, but I'm only going to compound it 4 times a month, or 9% at 12 times a month, which one should you take? Or 12 monthly, sorry. Should you take the quarterly or the monthly? I gave you 12% quarterly or 9% monthly.
12% quarterly.
12% quarterly because you're probably going to make more on your percentage, right?
Mm-hmm.
And if you go back, remember if you go up on your calculator, if you go up and highlight when you did the 4 and hit enter, you can go back and change the 9 to a 12% and see. You'd make 21,000. Oops, where did that go?
21,673 and 30%.
Yeah, you'd make 21,673 and 33 cents. So this is the compounding, the number of times it's compounding really going to make a huge difference in what you're making? No. So that's why these are important, because you as an individual in your life should be able to, this is fairly simple math to do, and you should be able to do it. It would help you make decisions. Okay, so continuously real quick. So in banking, continuously is every single day, yes? Okay, so A of 5 again. So 12,000 E to the 0.09. Oh, I put 0.05.
Times 5.
Yep. Times 5. Or 0.45, right? So $18,819.75. Did you guys get that? You're not there yet. Alex, did you get that?
I'm putting my calculator here.
Oh, you're doing something else. So continuously would be better, right? But is it giving you that much more? Yeah, not even $100, is it? So
How much?
$18,819.75. Okay.
Mm-hmm.
And that's it.